We are a university of about 20,000 students. Within our built environment, we have about 2,000 students. We are the largest university in the world in terms of PhD students, largest department. So there is no department of built environment with about 180 PhD students. So we are world's largest department in built environment in terms of PhD students. We are growing and there are several exciting things that are happening at Salford that you need to be aware of, and that's the whole purpose of this. So if you have any questions, let's keep it till the end, and feel free. I do want to have questions about. What I want to do is, we have been highly ranked in research. So research is one of our strengths. We have had some of the most leading researchers in built environment in the world who have either worked for us or have graduated with a PhD with us in last 20 years. So if you look at the prominent names all across the world, you'll find some link to Salford, okay, somehow. And that is something we are very proud of. Now, we also have recently tried to consolidate our research into a new research center, and I'm leading that research center. The research center is called BEST, Center for Built Environment, Sustainability and Transformation. Now, the reason I'm telling you about this is this gives you an idea of range of activities that we do within the center. So within this center, we have 3 major research groups, and I'm sure all of you can connect with at least one of these. So there will be something you will find exciting in at least one of these. Now I'm assuming most of you are civil engineers?
Yes, sir.
Is there anyone who is not a civil engineer? One. What's your background? You are mechanical. I'm mechanical also. Okay. So mechanical people can do lots of good things in built environment. I can tell you that. Okay. Now, within this center, when we launched this center, we said, we want to be an active, vibrant, and prolific global center for research. And our endeavor is to be recognized for its research impact and outcome. By the way, this is our new building, which has been built with about 60 million pounds, and part of our architecture group from Built Environment will be stationed here. This building is BREEAM Excellent rated, so it's a very energy efficient building, and this will be inaugurated in probably 1 month's time. So it hasn't been inaugurated yet. So from next academic year, we will be in business in this university. Now, we have 3 research groups within the research center. The first one is called the Built Environment Informatics Group. It deals with lots of issues, some of them like building information modeling. Now, how many of you have heard of building information modeling or BIM? Okay, some of you have. Now, BIM is the next big thing in built environment. So, if you really want to look at what is the future within built environment, you can't ignore BIM. BIM cannot be ignored at all. This is very important for all the BIM graduates. And I'm sure you might have some classes, Professor Sani, if he's here, then he's an expert in BIM himself. So I'm sure you have labs and all that you'll be dealing with during your program. So you're just starting. So during your program, you'll be starting. We have the Management of Construction and Property Research Group that looks more at issues such as project management, construction management. Again, lots of those issues some of you might have dealt with, some of you must be interested in. How many of you are interested in things like project management or construction management? How many of you? Any of you? Okay. All right. So this is our research group on that The third one is our Applied Building and Energy Research Group. Again, it's an offshoot of everything that James Prescott Joule taught us. Okay. But basically what this does is it looks at how you improve the energy efficiency of buildings and how you make them more comfortable and livable. Now our BIM group is led by Professor Jason Underwood, who by the way also leads our MSc program in BIM and integrated design. We were the first university in the world to start an MSc in BIM. So we have been quite way ahead of the competition. We have a very good setup for BIM in the university. Then you have a lot of things that we are doing within BIM. So we are looking at BIM information modeling. We are looking at how you can incorporate a lot of BIM related issues, lot of other features at design stage itself. So how you can design a building with appropriate energy consumption, how you can look at project management efficiencies, because what BIM does is you take the design. Now technically design is what? Three-dimensional designing. That's what a design is, right? You develop the three dimensions of the building. But what if you are able to develop things like process? What if you are able to develop a system, then you say, you know what, how long more will it take if I remove this wall from the building? Okay, how much will it cost me more? How much extra will it take? How many additional resources will I need? So you get all that information, okay, based on what is available, and you can predict. So basically, you know what, you are designing a building, and at that time you are looking at all the what if scenarios. If I remove this wall, what is going to be the impact on energy? And you can do all of that in a single piece of software. So what happens when you have clashes? Somebody put the plumbing in and somebody put the electric in, and then when the building actually started, they realized that they have been put at the same place. Now you have to delay the start for people to modify the designs or make a decision before you can keep proceeding with your construction. So that is what BIM is doing. BIM is giving you the power to make so many decisions at the design stage itself. Okay. Then we have a big GIS group, and what we are trying to do is we are trying to see how resources move. At the moment we have a project that is looking at, on a construction site, how efficient we are with movement of trucks. Okay. For example, there is this whole concept of logistics, reverse logistics. Anyone familiar with reverse logistics? No? Well, what happens on a construction site? You have one truck that comes and delivers the raw material, right? Bricks, concrete, whatever. It goes back empty. So it comes full, goes back empty. Then there is another truck that comes empty and picks up the waste. What have you done? You have just lost 50% efficiency, right? Because half the time the truck is empty. What if you can plan your construction process in such a way that the truck that comes with raw material leaves with waste? So you have saved on one truck, which translates into money. Now, it is very easy to say, the concept is so easy. It's not that easy to implement. Okay, so we have to use GIS. A lot of GPS support tools are there. There is a central planning system, because you can't have raw material come too early, because in Manchester it rains every day, so a lot of it would be wasted. You can't have it arrive too late, because your laborers, who are very expensive by the way, would be sitting doing nothing. So you have to plan it in just the right time. Now how do you do that? So we use a lot of GIS to do that. Then we have other information communication technology. This lab here is called Think Lab. This is a futuristic lab. What we had in mind when we started this lab about 8 years ago, 10 years ago, was, I'm sure you have heard of Airbus, one of the largest aircraft manufacturers, right? Now what happens in Airbus? In Airbus, different parts are designed and manufactured in different countries. Wings are manufactured in the UK, fuselage is manufactured in France, the tail is manufactured in Spain. So it's spread all over the European continent. But everything is synchronized very closely. Because remember, all these parts which are designed and manufactured separately will have to come together and fit. Otherwise the plane will not fly. So the aircraft industry came up with the concept of co-design or co-spaces, collaborative spaces. And about 10 years ago we said, you know what? If you look at any big building project these days, what happens? The architect is in the UK, the contractor is somewhere else, the designer and planner is somewhere else. What if they are able to design the building in 5 different countries using the same principle that Airbus uses to design its aircraft, and the building can come together seamlessly. So we have this lab which has the capability that people could be sitting in different countries designing it. And then if you see, this guy is wearing a virtual reality glass. So once the building is designed, you can put the virtual reality glass and actually take a walkthrough of the whole building. So you can interact, okay, and you can walk in the building. So we have this facility at Salford. It's a very expensive lab, very operational and world class. We get lots of visitors from there. So those are some of the major issues that we are dealing with in the built environment informatics group. Then we have management of construction and property research group, which is managed by Professor Peter McDermott. And what are the things we cover now? This is, we cover a range of issues within this group. We look heavily into lean. I'm sure all of you would get familiar with lean. If you are not already familiar with lean, how many of you have heard of lean? Okay, 2, 3 of you. But I'm sure by the time you graduate, you would have learned enough about lean. So we have a very strong lean research group. We have a procurement research group which talks about how we establish different contracts, different financial models. So things like public-private partnership, quite common these days. In India also, I'm sure you must have heard of PPP. Yes? So we have quite a bit of strength there. We also have a lot of strength in construction economics that deals with looking at life cycle costing, that deals with justification. You know, civil engineers come late when the building has to be built, but before the building has to be built, somebody has to go and make a case. Because the client who is eventually going to write the check will ask questions, right? Why do I pay for this? Why is it a good idea? Okay. What will I get in return? So we have a group that deals with that. We have people who are looking at supply chain management. Within construction, how many of you are familiar with supply chain management? How you deal with different contractors, how you synchronize the supply of things on the site. We are looking at community benefit management. You know, every time you build any kind of, especially public project, there needs to be a benefit to the community. For example, all these flyovers and new highways, somebody has to justify, okay? There has to be some benefit to the community. So we deal with, and we are starting, you know, we have this whole idea of social return on investment. Now there is social return at the time of construction because it provides employment to people. It provides employment not only to the people who are on the construction site, but also people who work for the contractors, the people who work for the suppliers, the people who work for the crane companies and the trucking companies. So all of this, it is there. We have a risk management group, and we just got somebody who manages a big software. So before a project starts, somebody has to identify risks, look at what are the implications and how are we going to deal with it. Off-site construction group, how many of you have heard of off-site construction? Any of you? How many of you have heard of prefabricated construction? Off-site is prefabricated construction. That's my core area, is one of the core areas is off-site, looking at how we can deliver buildings off-site faster, cheaper, better. Okay? So at the moment we have a project going on, but in the past I have worked a lot on several off-site construction projects. We are also looking at occupant behavior and how do occupants deal with different issues within the building. So once they come inside the building, how do we make sure that they behave well? They behave in a green manner. For example, you know, do you need all these lights? How many lights do you need? So that's energy part. How about how do you feel? Now, how many of you have worked or sat in an air-conditioned building for a very long period of time, 8 or 10 hours a day? Now, when you come out of the building, how many of you have felt sick, cold, strange? Do you feel that way? Yes? Dry skin, maybe a bit bloated. Do you feel that way? So we are looking at what are the things employees do in a building that lead to some of that. Because yes, there is air conditioning, but there is also lethargy. We have seen that in an air-conditioned space, people become too lazy. And we just did an experiment on how to make people move faster enough. And this was a very simple experiment. In the main corridor where most of the people used to use, we built the picture of Albert Einstein. And we put a camera there. Whenever people pass through Albert Einstein's picture, they would walk slowly. Okay? We observed them for 2 months. Then we removed that picture and put Usain Bolt's picture. Can you believe it? Everyone started walking faster. We didn't tell anyone anything, okay? It wasn't that we announced, okay, now we are changing the picture. We just experimented. We said, you know what, people need to move. And you know, during even the work time, they need to move and be physically active. How can we make them physically active? So Albert Einstein's picture, they will look at it, start thinking. Good for your brain, I like it. Physically, won't do anything. But for some reason, Usain Bolt, we just put the picture and people started walking faster. So this is the impact. So can, you know, you all are going to be dealing with some aspect of built environment. Can you manipulate people's behavior so that they become more healthy? So that is this whole area of research we are dealing with within the occupant behavior. How can we make people more active? And I'll come to some of that later on. Then we have this energy group which deals with energy house. We have a house, a full-fledged house built inside an enclosed space. Let me see if I have the picture here. Yes, this is our full-size house. So this is a 2-bedroom home, full size. It's not like a scaled-down replica. In fact, this is a house that is made of bricks from an actual house. In England, what happened was, after World War I and World War II, lots of houses were destroyed. So they built lots of houses because during World War II, there were lots of places that were bombed by Germany. Okay, so we have lots of these houses from that era that we can't demolish. So this was the house that was being demolished because it was not livable. We brought in the bricks because we wanted to get the feel of bricks from that area, that era. You know, how energy efficient was it. We even brought the windows and doors from that time. And we built this house. And now this house is in an enclosed chamber. So there is a completely temperature controlled chamber. And what we do here is we can simulate any kind of weather. So we can simulate rain, we can simulate snow, and we can simulate temperatures up to 35 degrees, which is probably the highest it gets in Manchester. Okay? And what we use it for is, you know, new window manufacturers or door manufacturers will put their windows and doors to check how energy efficient they are, how much energy losses are there, and you know, we will maintain the outside temperature. So if they want to test how this window will perform in winter, then we will put and we can reduce the temperature of this chamber to up to minus 25 degrees. Okay, so from minus 25 to plus 35, including snow, we can do all of that, and we can test the facility. So that is our energy house. We are quite proud of it. That are going on, that we are doing at the moment. We are doing a project called Modular Alliance, and this is my project actually. Now you see this house here. This is a typical 3-bedroom home that you will find in England. This is a typical 3-bedroom middle-class home. We assembled it on site in 8 hours. So we manufactured the whole house in a factory, shipping, and when I say manufacture, we even put the outer tiles and paints and everything in the factory. It even had beds and sofas inside. In fact, it had the bed sheet on the bed in the factory. Okay? We transported it. So this is how it looked like when we started building it. When we transported it, it was fully built. They had already done the groundwork. So all the utility and sewage and water supply was done. The house came at 8 a.m. Family had its dinner 5 p.m. inside the house. Okay. That's how fast you can do it using prefabricated construction. Because all the furniture was there, even the plates and glasses were there inside the building. Okay, so they had dinner inside the house on the day it came. So we are looking at this, and basically we are going to build 500 new homes in Manchester in 6 months' time in this project. So this is a project that is ongoing. We have quite a few partners. So Manchester City Council, which is the local municipality, is funding it. We are doing this project. Then we have another project which is looking at furniture design within buildings. So you must have heard of modular kitchens these days. They are becoming popular. Well, how can you use BIM more effectively to design modular kitchen? And how can you sit with the client and say, the client says, well, I don't like this, I want this. How can you use BIM, instantly change what they want, and then see how it will look like? So that is what the purpose of this project is. And again, they have developed quite a bit of BIM implementation in this. So that's a project that is currently ongoing. So at the moment, we again have another project going on with a construction company from China. They are building a big warehouse and office zone near Manchester Airport. And what we are looking at is again using BIM, how we can make them design it better. One of the key issues with this is a logistics city, so it's connected to the airport. So a lot of cargo will come and it has to be handled. So this building has to be designed to make sure that the cargo handling is optimal. So we are looking at that. So this would be the airport city Manchester in few years' time. And now we are also looking at Northwest Construction Hub, which is basically within the region of Northwest. We have brought in companies and we have established framework. So any government body that requires tendering, framework is basically like a pre-qualified list of contractors. Okay. In every tender there is pre-qualification. You might have heard the word pre-qualifications. Now in the UK what happens is, instead of getting pre-qualification done for every project, what you do is you establish a framework. Within this framework, you already have 5 or 10 pre-qualified contractors, suppliers, everything you need basically. So we were the first university to help the industry to establish like a framework of pre-qualified contractors within the Northwest. Now anybody, whether government, now within the UK, because at least now we are part of EU, the law says that anytime you have a government contract, it has to be open to everyone in Europe to pay. So when we established this framework, we got contractors from all over Europe, and now instead of going for pre-qualification in every project, they can come directly to the framework and it reduces the time it takes for tendering. So your construction project becomes faster. We also developed the UK government guideline on BIM. So now if you are bidding for any government contract, you need to be using BIM. And there is a maturity level that you need to have within BIM to be qualified to work on a government contract. Now we developed that standard for the UK government. Okay, again, this is quite prestigious for us because we can say that, now every construction project anywhere in the country uses this. Okay, so I'll just move on. Now we are working with HS2, High Speed Railway 2. What's happening in the UK is there are two high speed rail networks that are being developed. One is along the east coast, London to Edinburgh. And these are the trains that will run at around 300 miles an hour, the bullet trains. Okay, so that project is ongoing, it's in process. HS2 is the second line that will come to London, and from London it will go west to Manchester, Liverpool, and then go north back to Edinburgh in Scotland. So we are involved in, again, implementation of BIM on HS2 project. So High Speed Rail 2 project in the UK, again, a very prestigious project for us, 80 billion pounds. You can imagine how big this project is, and we are the BIM knowledge partners for that within Salford. This is one of my projects. I'm working with Highways England. Now generally what happens is, in the UK, when they have to repave the highway, they have to block the roads, right? Now we are trying to see how do we reduce the amount of time roads are blocked. How do we plan the whole paving process? So we have this whole simulation done for, basically they will close a stretch of highway at 10 p.m. because they can't close before that, and they have to open it by 6 a.m. and in that time we have to pave at least 1 mile of highway in 8 hours. Okay. So in 8 hours we plan how you divert traffic, how you manage traffic, how everything has to be planned just right, because asphalt is coming and it has to be laid, otherwise once it gets cold it's useless. Okay, so asphalt has to be laid as soon as it comes out. So we are managing that whole process, and by 6 a.m. when we leave the site, we leave with these lines and marking done. So it's not like, it is blank and then somebody will come 6 months later to paint it. When we say we have to finish that 1 mile highway, it means we have to remove the existing layer. You have to scrap the top, and then you have to put in the new layer. You have to put in the lines and all the signage, so that in the morning drivers won't even know something happened here at night. Okay. And then we are trying to see, now what we have done is, till about 2 years ago, they used to do about 0.75 miles in a shift. Now we have moved it to 1 mile a shift. So in 2 years' time, we have already gained almost 1/4 mile of paving in one shift, which is quite good. We are also working with visual management and looking at sites to see how we can improve site safety. So use of high visibility jackets, the fluorescent jackets. We also work with them to look at lean processes. So we work with them to see what are the things they are doing where they are losing efficiency. We do brainstorming sessions with the entire site crew, and so far we have managed to get about 20% additional efficiency out of construction site using lean. So lean is again a big issue for me, and this is one of my projects. We have, at the moment, we are in the process of doing 3D laser scanning of lots of bridges to see and do reverse engineering on process design. So what we are trying to do is, we do 3D laser scanning to see exactly how or what is there, and then we go back to the process and see how we can improve the process to deliver the same kind of overpass. Now this is an overpass. These are 2 lanes of a highway, okay? And there is a road going on top of that. So this is an overpass, very common, okay? So how do we ensure that all of this is done quickly? This is our Think Lab, and this is our virtual reality facility that I spoke to you about. You can see this guy has a virtual reality glass in it. You see him wearing the virtual reality glass here, and basically and all these guys are wearing virtual reality glass as well. And what he's doing is, he is walking all these 24 people inside the building. So this is the building, and they are taking a virtual walkthrough of the building, sitting at their desk, of course. But the good thing is they know exactly where every switch is, they know exactly where every room is, where every door and window is. So this is, we are quite proud of this, and we use it quite often with industry. We are also using this for planning whole districts. So for example, you can have a 3D model of a whole district with roads and homes, because that's available. You just have to superimpose Google Maps on it. Google Maps, if you look at the street view of Google Maps, you know where every building is, right? We have imported Google Maps, developed our virtual reality, and then we are modeling different aspects. So for example, crime rate or education levels. So we can see in 3D where crime rates are high. Okay, what is the best approach road for police people? If there is a crime at a certain location, how will they get there? Okay, so we can, the possibilities are endless with this facility. Again, looking at collaborative engineering, this is our city modeling. This is the 3D model of our university campus, by the way. This is our university campus. This is where the School of Built Environment is.